Hi everyone and welcome back. It's Kira Garfolo with Greenville Tech's Math 155. Today we're going to talk about section 2.3, which is interpreting and finding equations of lines. Remember from our last lesson that slope-intercept form is one way that we can write an equation for a line. For any line, almost any line at least, we can write its equation in the form y equals mx plus b. Remember that this m here, of course my pen doesn't want to work. This m here is going to be the slope, and the b is going to be your y-intercept. So this is the slope, and this is your y-intercept. If you have that information, you can easily sketch a graph. Just use your intercept and then use your rise over run for your slope to get some other points. Or you can just simply plug in those values of x and plot other points. Lots of ways to get lines. The only exception here is a vertical line, which remember is always going to be written as x equals some number. K is just some number. And that is because we cannot write it like that because y is irrelevant, okay? Remember, it's that undefined slope, so we can't talk about its slope. It is a vertical line. Now, generally speaking, our slope is the amount of change that we see in y, so the amount of vertical change, with a 1 unit increase in x. So if we continue going right 1 unit at a time on that horizontal axis, how far up or down are we going with each 1 unit step? Our intercept is the value of y when x equals 0. So remember, it's the y-intercept. So our x is going to be equal to 0. We're not going left or right any. We're just going up and down on that axis. So if we consider the example y equals 6x plus 200, that's in slope-intercept form. Okay, it could represent many, many different things. We see here that the slope is going to be 6. It's a positive 6. So that tells us that for every time we go up 1 unit on x, we are going to go up 6 units on y, okay? So rise over run is going to be 6. We're going to go 1 unit to the right and up 6 units to get to our next point. That 200 is going to be our y-intercept. And so that tells us that the line crosses our y-axis at a value of 200. When x is 0, y is 200. Or if you want to think about it, you can think of the point 0, 200. Okay. Now, in the real world, we're not just talking about equations for the sake of talking about equations. This equation could represent many, many different scenarios, okay? For example, let's say that y is the total cost of manufacturing x units, okay? So that would tell us that no matter what, we're going to pay $200, okay? Even if we don't make anything, we go on vacation, we just aren't making anything, whatever, we're going to have to pay $200. I always like to think about this fixed cost as something like rent, okay? You pay it no matter how many you make. Now, you could also think about that 6x, remember, is that unit is costing $6 to make here. So your cost goes up $6 each unit, but no matter what, you pay $200. On the other hand, you could also think about this. You know, there are a million scenarios we could come up with here. We could also say that maybe y is representing the height of a tree X years after planting. So that's going to mean maybe it's growing 6 inches per year, but it started at 200 inches tall. Okay, so when X was 0, when the years were 0, it was 200 inches tall. Let's look at an example scenario here. Let's say that Mike's yearly salary is given by the equation 18,000 plus 1,000x. And x here is going to be the number of years since 2015. So he was hired in 2015. And y is his total salary in dollars. Okay. So the first question, what has been his yearly raise since 2015? In other words, how much has his salary gone up per year? Well, that's going to be your slope. That's going to be that $1,000. Okay. Every year it goes up. Starts at 18,000 and the first year goes up 1,000, the next year goes up another 1,000 for a total of 2,000 and so on. What was his salary in 2015? Well, here we need to be careful with number of years since 2015. because here the years since is going to be 0 because it's 2015. There's no years since then, okay? So we could simply plug that in. Y equals 18,000 plus 1,000 times 0, and that's just going to give us 18,000. So he started at 18,000 in 2015. What if we wanted to say what his salary was in 2019? Well, how many years since? Well, it's now been 4 years, okay? So now we have Y equals 18,000 plus 1,000 times 4, which is going to give us 22,000. So now his salary in 2019 is $22,000. Let's look at another example. The height in inches of a human male is given by this equation. Y equals 3x plus 29. X here is the length of the humerus bone. Okay, the humerus bone is that one that's between your elbow and your shoulder. Everybody's seen the skeleton jokes that you find this humerus. I should have put that in the slides. But if we measure the length of that humerus bone, we can get an idea of how tall a human male is. So the first question that we have is, at what rate is the male growing? Well, the 29 is irrelevant to how fast he's growing. 29 is where it starts, okay? But it's telling us that for every, remember the rate is our slope. This is telling us for every 1 inch that the humerus grows, the height increases by 3, okay? So this is going to be 3 inches per inch, let's just say, of the humerus bone, okay? So for every 1 inch of their humerus grows, they're going to grow 3 inches taller. How tall will the male be if the humerus bone is 9 inches long? Well, now we're going to let X be 9. So we're going to have Y equals 3 times 9 plus. Okay, this is all. Looking at a graph. Sorry if this is, I don't know why it just kicked me out. Okay, sorry. Wouldn't be an online class without fun technology, huh? So even without stating that Y equals mx plus b, we can get a lot of information from that graph. Let's walk through some things that we can get here. What is the value of Y when X is equal to 4? Well, here's where X equals 4. And if we go all the way up, we see that this is at Y equals 6, okay? Now, what about the value of X when Y equals 4? These we just have to be real careful. Remember, Y is going to equal 4 right here. So what is X? Well, X is going to be 3. What is our slope? Well, there's a couple of ways to do this, okay? You could look at the fact that you have 2 points. You have 4, 6, and 3, 4 here, okay? So you could do that comparing Y's to X's, that rise over run calculation. You can also manually, just so you know, do a rise over run calculation by saying, well, how far do I go from this point to this point? Well, I go rise, I'm going up 1, 2, and I'm going over 1. So 2 over 1. That's going to be a slope of 2. But again, you could find any points you wanted on here. We can use these 2 points. There's a lot of other points that you could do. You could do this point or this point or this point or so on, okay? But we could get our slope mathematically by saying, okay, well, we know that we have 6 minus 4 over 4 minus 3, and that's going to give us 2 over 1, which is 2, which verifies what we saw just by counting. What about the y-intercept here? Remember, the y-intercept is where it hits this y-axis right here. And it's going to be right here, which is at -2. What about, lastly, the x-intercept? Well, remember, that's where it hits this flat axis, and that's going to be right here, which is going to be at x equals 1. I'm going to put y and x here. You could also put coordinates here. You could say that this is 0, -2. You could say that this is 1, 0, however you wanted to write that. Now let's say that we're using the exact same graph, okay? And let's say now that X is the number of years that a company has been in business. So they've been in business 0 years, 1 year, 2 years, 20 years, whatever. And Y is going to be our profit, okay? And the profit is going to be measured in hundreds of thousands of dollars. So here we're talking about profit. Here we're talking about years, okay? Let's think about a couple of important questions here. What point do you need to delete to make it realistic, okay? What do we need to get rid of? If we were going to show this graph in some sort of publication, what would we want to zoom in on? Well, the important thing here is that we're talking about years since they've been in business. So none of this over here matters, right? Because they can only be in business 0 years forward. They can't be in business a negative years. So I would delete, remember this is quadrant 2, this is quadrant 3, quadrants 2 and 3. Now, hopefully, you're only going to be concerned with this first quadrant, right? Ideally, but it's entirely possible that your profit could be negative, which would be in that fourth quadrant, okay? So maybe on year 3, not necessarily this graph quadrant 1 is important, but if you're talking about any business in general, you could have a negative profit. It's a bad year, right? Now, what would be the amount of profit for the company in the 3rd year it was in business? Well, we're going to go find year 3, which is right here, and we're going to go up. And we have this point right here. And we see that this is 0.34, okay, which we had talked about on the last one. So that tells us that it's been 3 years in business. Tells us that it is associated with y equals 4. Well, remember that our profit is in hundreds of thousands. So that's going to tell us that our profit was $400,000. And I managed to overwrite, but we can still read it. By what amount is profit increasing each year? Well, what is our slope? Well, we already saw that our slope was 2, right? From the last graph, same graph. But we could go up 1, 2, and over 1 to get to this point. So our slope is 2, but it's not going up $2 per year, right? It's going up $200,000 per year. Because remember, it's in that hundreds of thousands. Okay. Make sure that you take a moment and make that make sense. This is something that you much likelier than some of the other things you use in the real world. Okay, take a moment and pause and definitely get some practice with this one. I'm going to go on, but definitely pause and give yourself all the time you need. We want to use this graph to answer the following. What is the value of y when x is 3? Well, 1, 2, 3 over here. So we have this point right here, and that is going to be y equals 1. What about the value of x when y equals 2? Well, 1, 2. We come over here and we have this point right here. This is going to be at x equals 4. What is the slope of our line? Well, there's a few ways to do this, right? We can say, okay, well, we're here, so we're going to go up 1 over 1, up 1 over 1. Every time we go up 1, we go over 1. So our rise over run is going to be 1, right? So our slope is going to be 1. But you also have points here. We have 3, 1. We have 4, 2. You could always check that too. 2 minus 1 over 4 minus 3 is going to give us 1 over 1, which is just 1. What about the y-intercept of the line? The y-intercept of the line is where it hits this y vertical axis. It's going to be right here. That's going to be at y equals -2. And the x-intercept is right here, where it hits that horizontal line. And that's at +2. So that's going to be at x equals 2. If we want to write coordinates here, we could write 0, -2, and 2, 0, whichever way you prefer. Okay, let's continue on with more example work. Let's use this graph to answer the following. What is the value of y when x is 5? Well, 1, 2, 3, 4, 5. This line goes off forever because the arrows are there. Well, it turns out that our y is going to be 1, 2. What amount does y change when x increases by 2? Well, we could start here and say we're going to go up by 1, 2. Well, we didn't change our y. 1, 2, we still didn't change our y. It's flat, right? So we're not changing at all when our x increases. And that makes sense because look at this. It's a horizontal line. It has a 0 slope, right? So it doesn't matter how far left or how far right we go. It's not going to go up or down. What about the y-intercept of the line? Is there a y-intercept? Sure. It hits this y-axis right here at 2. Because y is always 2 here. So of course its intercept is at 2. What about the x-intercept? Is there an x-intercept? No, there's not an x-intercept here, right? Because this axis down here is never touched by that line because it's always at 2. So this is none. Do not write 0 here, okay? It is none because 0 would mean that it's hitting right here, but it's not, okay? So make sure that you say none. Now, I alluded to it earlier that you can find the equation of a line pretty easily if you're given it. You just need to find the slope and you need to find the intercept, okay? But the simplest equations are going to be those horizontal and vertical lines. And we discussed this in a previous lesson too. Remember that a vertical line has the equation x equals some number, okay? Remember that k is just some number. And it's the x coordinate of every point on that line, because that vertical line is always at the same value of x. On the other hand, we have a horizontal line, okay, where y equals b. And in this case, y is always the same. Remember, it's that flat line. It's not going up, not going down. And b is our intercept again, because that's where y always is. It's always going to be there even on that axis, okay? So in this case, we have a horizontal line. It's always going to be the same value. And in this case, we have a vertical line. It's always going to be the same x value. Okay? Vertical lines have x-intercepts. Horizontal lines have y-intercepts. Let's find these equations. So we see here that our line is right up here. And this is at 1, 2, 3. We know that it's horizontal, so we know that y is stuck on something. It's not going up, it's not going down, and it's stuck at 3. Now you could always look at some points to see which one's changing. Is x changing or y changing? But here we have y equals 3 because it's that flat y equals. Y is the one not changing. What about this one? Our line is right here if you can't see it. Well, now it's not flat, it's vertical. And so we know that we're at -1, -2, -3. We're at a set x value. And it's going to be at x equals -3. Okay? You'll see these on the test too, so certainly make sure that you understand these. Vertical has x, horizontal has y. Okay? Okay, let's talk through some more examples. What about the equation of a line that has a slope of 0, so m equals 0, that passes through the point 1, 1? Well, slope of 0 tells us that it's a horizontal line, right? If it's a horizontal line and it goes through the point 1, 1, if it helps, you can graph it, right? It's going to go right here. And it's a horizontal line. If you know that the slope is 0, whatever y value it is at x equals 1 is the same y value it is at x equals 1,000,000. So this is simply going to be y equals 1. Okay. What about the equation of a line that has an undefined slope that passes through 4, 3? Well, undefined slope is, remember, that vertical line. Okay. And it's going to go through the point 4, 3. So when it's vertical, our y's are changing. They're going haywire, but our x is going to stay the same. So this is going to be x equals 4. And you could graph this one too if you wanted. Let's see, 4, 3, 1, 2, 3, 4, 1, 2, 3, somewhere like this. And we know that it's vertical, so it's going to look something like that. Okay. Now, in the real world, it's pretty rare to have a perfectly horizontal and perfectly vertical line. In fact, most of the times in math applications, those are pretty boring. Most of the time, instead, we're going to have slopes. But don't panic. Even easier. We're going to use slope-intercept form. Remember that our slope is m, our intercept is b. Okay. The coordinate there is 0, comma b, because we know that we're not moving on the x. We're just going up and down on the y. This will come into play when it tells you points with starting x equals 0. So if we know the slope and the intercept, we can easily write the equation. We've worked backwards, right? If I gave you the equation, you can tell me about the graph. What if I just give you information about the graph and you can write the equation? That works just as easily. For example, let's say that we need to find the equation of the line having a slope of 5, so m equals 5, and passing through the point 0, 2. Well, remember that 0, 2, remember our y-intercept is 0, b. So this is going to tell us that b equals 2. And you could plot that point 0, 2 to make sure that, hey, that is actually, an intercept. So to do this, we now have everything we need. Remember, we want y equals mx plus b. We know that m is 5, and we know that b is 2. So we can write our equation just like that. Y equals 5x plus 2. Practice another couple. This is a great place to pause and make sure that you can follow. Let's find the equation of a line having a slope of 3 and passing through the point 0, 5. So here we know that b is going to be 5, and we know that m is going to be 3. Okay? So we have y equals mx plus b, which is going to give us y equals 3x plus 5. That's all we need to do. That's our answer. Easy test question, right? What about the equation of the line with slope 2/3 and a y-intercept of 5? Well, this looks a little different than our last example, but it gives us all the same. Has a fraction, but we're not really working with it, so don't be afraid of it. M here is 2/3, and b here is going to be 5. So writing, just like before, y equals mx plus b, we're going to get y equals 2/3 x plus 5. That's it. Now, sometimes you won't know the slope and the intercept. You may only be given 2 points on the line. To do this, we could do it by hand. It's not hard. It's kind of tedious, okay? You'd want to find the slope of the line, and then you'd have to find the y-intercept, and then you can use slope-intercept form, okay? So slope is easy with the 2 points. You'd have to then go in and solve to find your intercept with a little bit of algebra. However, we can also use our calculator. And our calculator will save us buku time here, okay? I'm going to show you the steps, and then we're going to walk through an example, okay? These steps are here more for your reference than to be memorized, because chances are you're going to do this enough, you don't need to memorize the steps. You're going to do it and practice it, and it'll just come naturally after you practice. So I will pull my calculator up to walk through an example, so don't panic, okay? But I just want to talk through how we do that. First, we're going to press data twice, okay? So you're going to press this button twice. You're going to scroll down to option 4, which is to clear everything, and press enter. This is good practice to do every single time, okay? Do this every time that you have a different problem. What it does is it clears out what you already had in there, okay? You may say, oh, I'll just overwrite, and maybe, you know, you can, but I'm here to tell you that you can overwrite 99 times successfully, and then you're going to miss one. You're going to add it too instead of overwriting, and it's going to mess up your results. I do it all the time. So now once you've done that, you can enter both of your X values in L1, which is that first list, and then you're going to scroll right to enter your Y values in L2. L1 is the first list, L2 is the second list. Make sure your points are in the same order, okay? So you want to make sure your ordered pairs are side by side. You're going to press second, and you're going to press data again. Notice when you press second and data, it's going to be that stat option. You want to arrow all the way down to 2 variable stats. Apparently this is option 2 on this one. There's one that we scroll all the way down for. I'm losing my mind, guys. Press enter, okay? When it asks you what your X data is, you want L1. That's usually correct by default, okay? Press enter and make sure that for Y data, it's L2. This is telling the calculator that, hey, my X's are in this first list and my Y's are in the second list. You want to scroll down to highlight calc and press enter. It's going to give you a bunch of output, okay? You don't need, especially at this point in our class, most of that output. Your slope is given by A. It is not given by M. That is probably the single hardest thing to remember here. The calculator gives you your answer as Y equals AX plus B. You need to look for the value of A and the value of B in that pile of output that it's going to give you. Okay, so you can write, when it gives you A, you can write your equation, A and B, plug them in, and you get it just like before. Just remember that M is A, which is your slope, okay? Let's give this a try. We want to work through an example. We want to find the equation of the line passing through points 2, 7, and 5, 13. We want to verify that we're going to get Y equals 2X plus 3. So hold on one moment, guys. We want to make sure we go in. Sorry, I had to reboot right before I started this. I already activated this, really? Okay, hold on. I'm going to pause my recording. I'll be right back. Double check that. Okay, so as we were working on that, we had the example with 2 points, 2, 7, and 5, 13. So remember to do this. We are going to press this data button here twice. So press it twice. You want to scroll down to clear all, that option 4, and press enter. Then it's going to bring you here, and it's going to show you the blank thing. Okay, so this is L1, this is L2. We won't use L3, at least not anytime right now. Okay, so now we want to enter our values. Remember our example, our first point was 2, 7, and the second was 5, 13. So our X values are 2 and 5. Then we need to go over and put our y's in. Now remember, they need to match. So we need to put 7 first because we put 2 first, and then 13. And you want to look here and make sure that you see the point 27 and 513. They're in the same rows. If you mix them up, it's going to totally mess up your answers, okay? Once our data is there, we're going to press the second button, and we're going to press data again. Remember, that's going to turn it into stat. And we want the option of 2 variable stat. Scroll down and press enter. Now, by default, this should all be good. Our X data is in L1 and our Y data is in L2. As long as you follow these directions, you don't ever need to change that. And you want to go down to where calc is highlighted and flashing and press enter. Now it's going to spit out all kinds of information here. And we don't need to know any of these right now. There's some that we'll talk about in a later section, but a lot of it is just beyond the scope of our course. Scroll down. Remember, we're looking for A and B. A is our slope and B is our intercept. So scroll way down. And there we go. A equals 2 and B equals 3. Now, if we go back to our slides here, it said, hey, we should get Y equals 2x plus 3. And that is, in fact, what we got. Remember, we got A equals 2 and B equals 3. And in the calculator, it's going to be Y equals AX plus B. So Y equals 2x plus 3 is indeed what we got in our calculator. Okay, let's give it another try. Let's find the equation of the line through the points 5, 3, and 2, 9. So we're doing the exact same thing. Go back to our calculator. We're going to clear everything. Okay. Now start the exact same way. Press data twice and scroll down to option 4. Clear everything. Now enter your X's. So we had 5 and 2. And now enter your Y's in the same order, 3 and 9. Do a double check to make sure, yes, points are 5, 3, and 2, 9. So we're good. And then we're going to press second data again, which is the stat option. 2 variable stat. All of that is correct. X is in L1, Y is in L2. And press enter. Now remember, we have to scroll way down here. And we're going to get A is -2 and B is 13. So we can write this as Y equals -2x plus 13, because we had A was -2 and B was 13. Now, certainly by this point, you need to pause and make sure that you can do this next example. I'm going to walk through it. Make sure you get the right answer here. I'm going to press data twice. And I'm going to scroll to my fourth option and clear everything. Now I want to put my X values in. So I had 2 and -3. Remember to use the negative sign, not the minus sign. It'll yell at you. And -3 and 2. And we want to check because it's easy to make a mistake here. We had points 2, -3. Oh, see, I did mess up. We had the points 2, -1, and -3, 2. See, always double check yourself. Make sure you didn't mess up. Once we have that in there, we're going to press second data and go to stat, our 2 variable stat. Everything there is good. And scroll all the way down. So here we see that A is -0.6 and B is 0.2. Okay, so we can write this equation just like before. A is negative 0.6, B is 0.2. So y equals ax plus b is going to turn us into y equals negative 0.6x plus 0.2. And that is our answer. Now let's talk about a slightly more applied process for this. Same math, we're just going to use it in an application. Let's say that our temperature is presently 75 degrees and it's rising 3 degrees each hour. We want to write the equation for the temperature x hours from now, where y is the temperature in degrees Fahrenheit. Well, we don't have 2 points, so we're not going to use the calculator method that we just saw, but we're going to use one of the other methods that we talked about at the beginning of class. We know that it's currently 75 degrees and it's going up 3 degrees each hour, okay? So we know that right now, hours from now at 0, it's 75, okay? Notice that this is our y-intercept. And we know that it's rising 3 degrees each hour. So we know that our slope is going to be 3, okay? So if we want to write this equation in y equals mx plus b, this is simply going to be y equals 3x plus 75. Okay, we're going up 3 degrees each hour, so that's our slope. And we started at 75, so that's our intercept. Let's talk about another practice problem. A car costs $25,000 when it is bought, and it's worth $17,500 5 years later. We want to find an equation relating its value, which is y, so the dollars are y, to its age, x. So here we can talk about 2 different situations. You could write coordinates. I'm just going to make a table saying I have x values and I have y values. I know that right now when I purchased it, its age was x equals 0. And then I also know that I'm talking about 5 years later, so its age would be 5. So those are my x values. My y values, when I first bought it, it was $25,000. And then 5 years later, it was $17,500. Okay. Now we have 2 points to use our calculator. Definitely pause and make sure you can get the solution. Let's put these in here. Data twice. You can just type number 4 if you want to not scroll to 4. And let's input these. We had 0 years and 5 years. And we had $25,000 and $17,500. Do a quick check for typos. We're good. Press second stat. 2 variable. All of that's good. And scroll down. Here we see that A is negative 1,500 and B is 25,000. So we can go back and write our equation. It tells us that A is negative 1,500, B is 25,000. So if we write this, we have y equals negative 1,500x plus 25,000. And that's our answer there. Okay. Make sure that you can make sense of this and always do a practicality check. It makes sense that our slope is negative because it's decreasing in value, right? That whole depreciation concept. And it started at 25,000 when it was 0 years old. So that makes sense. Let's do one more. If a bush is 5 feet tall after 3 years and 8 feet tall after 5 years, find the equation of the line describing its growth, where y is going to be the height and x is the number of years. So we can say, okay, well, we have 2 points. We have x's and we have y's. We've looked at it after 3 years and we've looked at it after 5 years. So our x values are 3 and 5. And our Y values at 3 years, it was 5 feet tall, and at 5 years, it was 8 feet tall. Okay. So we can put these in our calculator. Just like this. We're going to do data twice. We're going to clear it. And we're going to say, okay, we know we had 3 and 5 and 5 and 8. Double check for typos. Press second data, which is stats. Go to that 2 variable stats. All of that's good. And scroll way down. There we see A is 1.5 and B is 0.5. Okay. So if we go back here, we know that A is 1.5 and B is 0.5. We say, okay, well, Y equals AX plus B. So our Y must be 1.5X plus 0.5. That's telling us that it's growing 1.5 feet per year. And when we first planted it, it was only 0.5 foot tall. Please, 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 I can't urge you enough to make sure that you go through these and you understand and that you can get these solutions. You will see similar questions on homework. You will see them on the test. Remember that there are a lot of ways to get help. Okay. Remember here that we can tell a lot about a line just from its equation, or really just from looking at the graph. Maybe somebody just tells us about the graph. We don't have to know all the pieces of the puzzle. We are smart and we can use our references. As long as our line is not a straight vertical line, we can write the equation in slope-intercept form. Okay, remember vertical lines have undefined slope, so that puts us in a pickle. Use the calculator when it's convenient. Usually to use the calculator, you're going to want to have 2 points. Okay, you're going to use that 2 variable stats. Please be sure to get lots of practice here. Where can you get more practice? Well, textbook, chapter, okay, within that section. There are textbook practice at the end of each section. There are textbook even in the review section here, like section 2.7, I believe. You can watch those supplemental videos by the other instructor. And if you need more help, where are you going to go? You can do the Math Center. And you can ask me if you've certainly exhausted those textbook efforts. I do ask that you try to look at your textbook first, because sometimes if you walk away, take a deep breath, and come back, you're good to go. So you saved yourself some time. I'm always happy to answer emails or office hours or whatever, but a lot of times you'll retain it better if you use your resources to find it yourself. That's all that I have for this section. I will see you next time, and we're going to start talking about my favorite thing as a statistician. We'll talk about a little bit of statistics. Thanks for tuning in as always, and I'll see you next time.